Arrangement of books. So a bookshelf has 3 math books and 3 physics books. So these are M1, M2, M3 and P1, P2, P3. If so, since there are 6, the total number of possible ways they can be arranged is going to be 6 factorial, which is 720. After a few days, any of the 720 arrangements would be equally likely. So the possibilities of any arrangement happening is going to be 1 over 7 by 20. What is the chance that, so the question is, what is the chance that I will find all math books together? Okay, so let's think of the arrangement. You have to assume that math is one little bucket here, and then the other spaces are occupied by the physics books in any combinations. So there are basically now 4 bundles which can arrange anyways. So you can have this arrangement, or you can have a P1, then a math arrangement, and then a P2 and a P3 arrangement. So all this thing can be arranged in a 4 factorial manner. But within this math bundle, the M1, M2 and M3 can be arranged in 3 factorial manner. So 4 factorial is 24, while 3 factorial is just 3 times 2, which is 6 times 1. So altogether, arrangement can happen is 24 times 6, or 144. So the thing to remember here is that what has made this different is, instead of 6 factorial, now we have a 3 factorial of the math book, which we are just multiplying with the whole combination, which is 4 factorial. So that is why this arrangement is possible in 144 ways, and so altogether arrangement is 44. So the probability of this arrangement happening is 144 out of 720. So in an event, it's given to you and you are asked to calculate the probability of the event. All you need to calculate is the count how many outcomes are going to lead to that probability. So we need to calculate how many outcomes are going to lead to that event, and there are total 144 such possibilities out of 720. Now we have a question. We change the question to, what is the probability that all physics books will be together and all math books will be together. So now again the sample space is still 720 or 6 factorial, but now the event is just blocked into 2 bundles instead of 6. So we have 2 big bundles now, M1, M2, M3 and P1, P2, P3. 2 can be arranged in only 2 factorial, which is basically 2, but this can be arranged in 9 possible ways and this can be arranged in 9 possible ways. So what you have here is the bundle of 3 and 3. So this is 9. This is 9 times 9, which is not correct. So this is not 9, this is 6. So this is 3 factorial, which is 3 times 2, and this is 3 times 2, so that is 6 times 6, and these two, and then these two can be arranged in 2 possible ways, so that will be 2. So this will be 6, 6, 36 times 2, that is 72. So the possibility of this arrangement happening is 72 out of 720. Now suppose we ask a question that after a random permutation, neither the physics books are together nor the math books are together. So for this we make a diagram of math books together, physics books together. So this is represents the math books together, and this represents the physics books together. And they are both are together. But we want to know the area of this when none of them are together. So if A represents the math books together, A represents the math books together, and B represents the physics books together, the probability of both are together, A union B, will be probability of A plus probability of B minus probability of A intersection B. Which is either of them are together. So how do we calculate the probability of, we calculated this probability that physics will be together and math will be together, which is the AND probability, they both together, which is this one area, which we had calculated earlier as 72 out of 720. But we want to know OR, which basically means this area. So this is PA, PB, and so we need to know PA, which is the probability of math books being together. So probability of math books being together is that the math is one little bundle here and the physics is 2, 3. This can be arranged in 4 possible ways, and within this there are 3 books, so 3 factorial, and this whole thing is 4 factorial. So this is 4 factorial multiplied by 3 factorial divided by 6 factorial, that is equal to 24 times 6 out of 720, that is 144, which we also had calculated previously here, the same thing. So PA is 24 out of, same would be PB, which will be 144 out of 720. Thus, when we calculate the probability of A or B is going to be 144 out of 720 plus 144 out of 720 minus 72 out of 720, which is going to give me 216 out of 720. But we are interested in its complement, that the neither are together, which is going to be 1 minus 216 out of 720, which is equal to 504 out of 720. So this is the ways we can calculate. We have to find the possible ways that the combination can happen. We have calculated what are the ways that I can find all math books together. We have calculated all physics will be together and math books will be together, and then we calculated neither the physics will be together nor the math will be together, where we have to use this A or B and then use the principles of complement to find it out, and the answer would be 504 out of 720.